All right. So we discussed about application load balancer and how Istio service mesh being a powerful software which abstract the network and communication out of the core application logic can be used as an application load balancer, an API gateway, and can be used to attain a lot of advanced networking functionalities in infrastructure. So, we'll discuss about how Istio resources or the CRDs can be used uh, for achieving a very rudimentary network functionalities, that is configuring it as an application load balancer. Now, for this demo, what we've done is we have created two deployments or two versions of deployments for a service called Eco Server service. And we'll see, whenever we are trying to reach out this Eco Server service, how is to load balance the total traffic. All right. So to start with this, we have one deployment file. We are basically using Eco Server image. So in the Docker Hub, we have stored this Eco Server. So you can give the link. And our deployment version 1 YAML, in that we have mentioned the replicas. There has to be three. There will be three pods which gets created. And we have mentioned that the app name is Eco Server and the version is 1 v1. So this is the deployment YAML, and we have mentioned, and yeah, and the container port is 80. So the application runs on 80. We have mentioned the service called Eco Server service. And we have mentioned the deployment. We have put that in the selector, and the port is 80. And we have ensured that this service listens all the HTTP request. So that's the key idea. And we have created another deployment of the same name, Eco Server, and with three replicas, the same application which will run in these three replicas, and we have configured as a version 2. So basically, there'll be six applications which will be running, in the six pods, and three of them is version 1, and three of the pods which are mentioned in deployment to YAML will be of version 2. Now this is interesting because such kind of instance will arise while implementing canary deployment. For example, you have an older version and now you have a newer version which you're going to deploy or release to the production. Then perhaps you want to have the same replicas, you want to call it a version 2, and you want to split the traffic. You want to gradually increase the traffic from 0 to maybe 100% gradually to the new version. In that case, this is essential to have two separate versions or two subset of the same application. In this case, we have Eco Server and Eco Server service, and under that we have version 1 pods and version 2 pods. That's how we have configured it. Now, our Eco Server service will not receive the traffic from the public. That's why we have mentioned Istio Gateway. Now, Istio Gateway is the resource provided by Istio Service Mesh, which will um, help you to get the traffic from external traffic from the public. So we have mentioned Istio, Ingress Gateway. We have mentioned that it would listen at the port 80, and then it would take all the HTTP request from the internet. So in under host, we have mentioned that it will take a listen for all the host. Now for all, it'll Istio's gateway would listen to the external traffic, but to apply certain rules and logics, Istio provides virtual service resource. In that, we have mentioned that once the request comes to the gateway, parse the URL, and here we have mentioned for all kind of URL, the root URL, you can send the destination that is Eco Server service. We've mentioned that, which and it would listen to port 80. So that's what we have mentioned, and we have mentioned the route that for version one of Eco Server service, we will send 20% of the traffic, and for version two of Eco Server service, we'll transfer 80% of the traffic, or we'll route 80% of the traffic to the subset application of the same service. Now, Istio also provide destination rule. If you have two different separate applications, it is quite easy to achieve with virtual service. But in case if you have the same service, and you have two separate instances or subsets or two separate versions, V1 and V2, like we have in this example, Istio provides a destination rule. Just to mention that v1 refer to the version 1 of the deployment, and v2 refers to the version 2 of the deployment. So that's what we have mentioned over here. So now what we're going to do is we'll apply all these resources to our namespace, and we'll see how Istio kind of take fetch the external traffic and load balance it between the version 1 and version 2 pods. Let's get started. Let's deploy all the resources. First, I'll just quickly see how many namespace we have. So namespace. So I think we have 8 namespace in this cluster. I'll use deb-ns. This is my namespace I've created a couple of days ago. I'll just use it to deploy all these resources. So what I'm gonna do is I'll just apply kubectl, apply, yeah, I'll apply the first version, and I'll apply it to my namespace deb.ns. All right, so I have applied the first namespace. Now let us just quickly check how many pods we have. All the pods in this namespace should have been created right now, maybe in some time. Just let's see. If you see that, just before 18 seconds, these 3 pods are created. Eco Server demo version 1. All right. So this is my version 1 Eco Server. Now let's go ahead and apply this our second version. That's V2. So this is my V2 where I have created, deploying the same application, 3 replicas. Let's just go ahead and apply the here. All right. So our, both the, versions of the applications are deployed right now. So as you can see, there are 3 pods of version 1 and 3 pods of version 2 are running in my namespace. All right. So right now, obviously, these pods cannot listen to external traffic. For that, we need to apply our Istio gateway. So let's go ahead and apply this. Apply -f. So it's ALB gateway. I think I have applied it to the, so if I do not mention any namespace, then it gets deployed to the default. I'll just delete and reapply the Istio gateway to our namespace. All right, so it's deleted. Right now, let me apply in my own namespace. All right, now the gateway is created. All right, so let's kind of apply or deploy the virtual service and the destination rule as well. So virtual service, here we go. Virtual service is deployed, and then we'll also deploy our destination rule. Here we go. So basically we have deployed our application, two versions, one gateway resource to listen at the port 80 from external vault, and then a virtual service to route those traffic to the eco server service. That's the plan. And destination rule to make is to understand that there are two version 1 and version 2, which has to be addressed properly, or which is mentioned in virtual service. These are the nothing but the v1 and v2. Okay, just to kind of make is to understand. All right, so now we have implemented. Now let's go ahead and kind of send some traffic and try to access eco server from our browser. And perhaps we'll see that 80% of the time, if we try to hit eco server from the browser, it should reach to version 2, and 20% of the time it should reach to version 1. That's how Istio should load balance it. All right. Now to get that, what? Oh, I'm sorry. Now, to get that, we need to first of all we need to get the IP of our Istio gateway. Now we'll get the IP, the external IP of our Istio gateway. For that, we'll just write kubectl get service, then Istio systems. Let's see. Let's wait for the result. Okay, okay. Is your system. Okay. All right. So if you see, I have mentioned service. These are Istio Ingress Gateway and Istio OT. These are the two components of Istio when you install it. A new namespace gets created, Istio system. And we're going to take the external IP of Istio Ingress Gateway. We have created the resource called Gateway of Istio Ingress Gateway kind to mention that we will listen in certain ports, etc. But we can take the external IP here, and then we can just put that in our browser to access our eco server. All right, so let me kind of open my browser. So I'll just paste the external IP in my browser, and I should be able to, yeah, here we go. So we have our request is to kind of reaching out to eco server service, and it is reaching out to version 2. If you remember that we have written the regular expression in the virtual service resource that 80% of the traffic should go to version 2 application, and only 20% should go to version 1. And each of these versions had near about three pods. So all our kind of requests from this browser, Istio will accept at the port 80, and then it will route most of them, 80% of them, to different ports of version 2. I'll just refresh and you can notice. So now it's version 1, version 2, first one pod, version 1, another pod, version 2, another pod. So you can see, the pods of version 2 application is changing. All right. So that's it gives an essence that most of the traffic goes to version 2. Now that's how Istio load balances traffic. We can also deploy sleep application, because from the browser it might not be clear. I'll deploy one sleep application, and we'll try to curl to eco server service from that sleep command, from the sleep service, and we'll see how much traffic is getting routed to v2, and how much traffic is going to v1. So now we'll deploy the sleep service, and we'll try to get one of the pods. So let us first deploy our sleep service, kubectl apply -f sleep, and then our namespace DNS. So, okay, the sleep service got created. Now we'll see, get into one of the pods. We'll get the pod name, get pods. We have to provide the namespace. Cool. So now we'll get into one of these pods. So for that, we'll so sleep pod. I'll just copy it here, and then we'll write kubectl exec it, then the pod name, and then you have to mention the namespace. Otherwise, it will not open. If you are using the default namespace, that's fine. Otherwise, you have to mention the namespace, specifically to get into the shell of this pod. All right, cool. So now we have entered into one of these pods, sleep pods, and we'll run a command to curl our echo server for 10 times. So for that, what we're gonna do is we'll just kind of write a loop function. I'll just uh, write a loop, just a minute, for I in 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So the loop will run for 10 times, and I will curl um, our echo server. Obviously, you cannot just create, reach out to echo server. You have to use the IP for that. Our IP was, Istio Ingress Gateway IP. So our IP was 20.232.255 dot 8, and then we'll use, uh, you know, our host name. Just to identify which particular pods we have reached out to. Then yeah, let's see. All right. If you see, we have made an external request from one of these pods to echo server using Istio gateway. And as you can see, uh, we have reached out to V1. There are three V1s, and 70% of the time there are V2s, V2 pods. So that's the idea. Istio will automatically load balance the traffic. So we have done this exercise for curl exercise just to give you an idea about how Istio will load balance it. So all right, in case if you need any help on implementing Istio, then IMESH will help you. So Istio is extremely powerful software which can be used for advanced load balancing, advanced network management, implementing your security using MTLS or any kind of authentication or authorization for both internal communication between microservices and also your communication at the edge. So do let us know if you need any enterprise support for Istio Service Mesh. IMS helps large clients. We provide consulting services to implement and adopt Istio. Thank you.